going to talk about single variable inequalities. And before we get started, let's talk about what the inequality symbol is. So here on the screen, for the first one, we see is less than. The other one is less than or equal to. Then this one it's greater than, and then finally we have greater than or equal to. Now the most important thing is that you could think of like the inequality symbol as a monster, and it wants to eat the bigger number. For example, 3 question mark 5. So if we were to make this inequality be correct, we want the symbol to eat the bigger number. So in this case, what I mean by to eat the bigger number, think of this as a monster, or back in the old days we called it Pac-Man. And so the Pac-Man wants to eat the 5 and not the 3. Whereas for 7, comma 10, um, what direction does the monster want to face, right? The Pac-Man, it wants to face towards the 10. And in this case, I could also make it less than or equal to. I could do these for both, and I will mention why briefly. Finally, let's say, hey, 3 blank -2. So what's bigger, right? It's the 3 or the -2 bigger. In this case, 3, it's a bigger number. So the symbol, the Pac-Man, it wants to eat the 3. So the mouth, it's going to be facing the 3. So let's compare this problem here. Here I have x is equal to 1 versus x is less than or equal to 1. So what is the difference? For the first one, x equals 1. This means that we only have 1 point. So in other words, one solution. When we have equality, so in other words, equality implies one solution for the single variable case. Whereas when we have when we have an inequality, we want all the numbers less than or equal to what? 1. So in other words, the way how we approach this is that we draw a number line. I like to label whatever this number is the 1, and notice the way I read it, we want x's less than or equal to 1. So in other words, we want numbers going to the right. So here's a 1. So numbers to the right of 1 are bigger, and numbers to the left of 1 are smaller. Okay, so but in this case, we want to find all the x's that make this statement true. So in other words, we have to head to the left. I may have said right, but I meant left. So in other words, I'm going to shade for illustrative purposes, but a more common way of writing this, we use this notation here. And what this means is that we want all the numbers from -infinity to 1. And another way of writing this, it's a closed circle form. These symbols mean the same thing. When you have a bracket in a closed circle, it means that we're including the point. So in other words, the values of x that make the solution are all of these points. And remember, there's an infinitely amount. In other words, from -infinity to 1 will make this statement, x is less than or equal to 1, true. Whereas when we have x equals 1, it's only one solution. Great. Now I'm going to compare these. Notice that here we do not have the bottom mark. This is the less than symbol versus the less than or equal symbol. So for this one, again, whatever number you have, just draw an arbitrary line and write the number 1, aka do a number line. So now we want to focus on the x's that make this statement true. So we want x's that are less than 1. So in other words, numbers to the right of 1 are positive or larger. Numbers to the left of 1 are smaller. So we want x's that are smaller. So in this case, we're going to shade this way, or draw our ray this way, the line. versus, again, we just did this one. The same thing, we're going to put a 1, but we want this. So notice that the diagrams kind of look the same. The difference is our choice of symbol at the end. So here I used a parentheses, and here I used the bracket, and this is the main difference. For this and this, for this and this symbol, we use parentheses. For this and this, we use brackets. And the reason being, it's that here, it's understood that we can get very close to 1, but not touch 1. In other words, it cannot equal 1. Whereas to here, we can get very close to 1, but we can touch it. In other words, we can also include 1, and we can also include 1, and not just close, but any number here works, including the 1, and it will make this a true statement, i.e. 1 less than 1, negative 100 is less than or equal to 1. Whereas here I could put 0.9999, it's still less than 1. What if I put negative 1,000? That's still less than 1. So these are true. But if I were to say, hey, 1 is less than 1, it will be false, because remember, it's implied that we cannot include the number itself as a solution. It has to be all the numbers smaller than 1 and not including 1. Whereas here, it's all the numbers smaller than 1 and also including 1. Okay, so now that we reviewed the basics, let's get down to more difficult problems. So we have this problem here, 2x plus 3 is less than or equal to negative 5. And again, the way how you treat these is you're solving for x. So we're going to pretend, right, that this is an equal sign. And from the previous video, we know how to do this. So in other words, we want to isolate x equals, and we'll put parentheses because we're pretending, blah, blah, blah. We don't care what the right-hand side is. We just want to get x alone. Okay, so let's do that. So in other words, since I want the x alone, I'm going to move the 3 to the right-hand side. Remember, in algebra, when you move things across the equal sign, you have to do, or pretend equal sign in this case, we do the opposite of what it says. So in this case, it's going to be minus 3. So I get 2x less than 6, 7, negative 8. Fine. Now again, I don't want 2x, I want x. So I'm going to divide both sides by 2. So I get x is less than negative 4. Now, we could stop here, but oftentimes a teacher would say, hey, now draw the solution or graph the solution. So again, earlier, we just drew like a number line. Whatever number this is, you place it. So that's going to be negative 4. And remember, we want x's that are less than. So in other words, x's that are smaller than negative 4. And x's that are smaller than negative 4 are to the left. So in other words, my answer should be this and this. So this would be how I would write it. Cool. And great, that's fun and all. And notice that I use a parentheses because of this symbol. I cannot include it, so therefore it's not a bracket, it's a parentheses. So in other words, the answer, if you want to do it in like in a smart ass way, it will be negative infinity 2 comma 4. And I'll make a separate video on set builder notation. This is called interval notation, but I'll make a separate videos on both interval notation and set builder notation. But for now, we're just gonna write our answer this way and do a number line. All right, cool. Now, what if I changed the problem a bit and I was like, hey, negative 4x plus 5 less than negative 2x plus 7. This is a bit more interesting, right? It's more involved. So again, the goal is to isolate x on the left, or the right. It's arbitrary, but I just out of habit, I put everything on I put the x's on the left. So again, if I want to move things across the symbols in algebra, or pretend equal sign in this case, I'm going to minus the 5 on both sides. So I have minus 4x is less than negative 2x, and 7 minus 5. Guess what? That's 2. All right, cool. But notice that I have x's on both sides, and I don't want x's on both sides. So I'm going to move this negative 2x to the left-hand side. And since it's a minus 2x, that means I'm going to add a 2x to both sides. So I get negative 2x is less than 2. Okay, perfect. Now, here it's where the main note, this is like the major, this is the second major difference between inequality, just between the inequality symbols and the equal symbol. And what I mean by that is, notice I have negative 2x, right? If this were, let's say, equals 2, then I would just divide by negative 2 both sides, and my answer would be negative 1, and I will be done. But here, since we have an inequality, I must mention one rule here, that dividing or multiplying across the inequality symbol reverses, in other words, changes direction. So for here, if I divide by a negative 2 on both sides, the direction of it will change. And what that means, it's going to be, instead of facing this way now, it's going to be facing that way. So I get negative x is, in this case, greater than, sorry, not negative x, I just divided. It will be x, it's greater than negative 1. Great, and that would be our answer. But remember, we want to also graph it. So again, I would write the negative 1. And remember, I want x's that are bigger because the Pac-Man wants to eat the larger number, the monster. So numbers to the right of negative 1 are bigger. Numbers to the left of negative 1 are smaller. So in this case, we want x's that are bigger. So we're going to go to the right. And the symbol, recall, we use a parentheses. So this would be the solution if you want to graph it. And for interval notation, and I'll talk about it later in another video, it will be negative 1, 2, we're going to goes on forever to infinity. Great. Now let's do one that's like a bit tricky. What I mean by tricky, it's notice that we have two negatives. So let's talk about it. And it's not tricky because why? Here again, I want x on the left hand side. I don't want negative 2. So I'm going to divide both sides by negative 2. And when I divide both sides by negative 2, guess what? The symbol must also flip because I divided across by a negative. This, again, this is always true for inequality. So I get x is less than negative divided by negative, positive. So I get 7 halves. And again, you draw your number line, place the number that you have, 7 halves. And I want x's that are quote unquote smaller. So in this case, I have to go to the left of 7 halves, and remember it's a parentheses. So it would be 7 halves, and remember it's all of the numbers here which make this inequality true. So for this problem here, we have fractions, and that's okay because you remember that in algebra, if we have an equation and quote unquote pretend equation, what I like to call the inequality symbol, the first step that we should think about always when we have fractions, it's to clear the fraction. And recall from the previous videos that I have posted on solving equations, the way how we clear the fraction is that you find the LCD of every term, once you find the LCD of every term, you you multiply every term by the LCD. And in this case, the LCD, notice that our numbers in the denominator are 3, 4, and 6. So in other words, I have to find the LCD of 3, 4, and 6. And there's multiple ways of doing that. One of the easiest way, it's like list the numbers out and then list their multiplication table out. So we have 3, 6, 9, 12, 15, 18, etc. For 4, we have 4, 8, 12, 16, 20, 24, 28, etc. And for 6, we have 6, 12, 18, and 24. And the LCD would be the first number that they all have in common. So looking at my list of numbers, the first number that they have in common is 12. So in this case, the LCD, it's what? 12. So going back to our problem now, I'm going to multiply every term by what? By 12. So I'm going to write 12 and write 12, and in the middle, parentheses, plus 5 fourths greater than 7 sixths. And again, we're going to simplify. In other words, 3 goes into 12 4 times. So I'm writing 4 here. 4 goes into 12 3 times. So I put it there. And 6 goes into 12 twice. So I have there. Now, what I really have, it's 4 minus 4 times negative 2x plus 3 times 5 greater than or equal to 2 times 7. So simplifying, I have the first term, I have negative 8x. 3 times 15, it's what? Sorry, 3 times 5 is 15. I gave you guys the answer. And then 2 times 7, it's what? 14. So now I could solve this as usual. So I'm going to subtract 15 on both sides. So I get negative 8x greater than or equal to negative 1. And then now, notice that I have a negative 8x, but I don't want negative 8x. I want just x. So I'm going to divide both sides by what? Negative 8. But remember, because I do that, I have to what? Flip the sign because I divided across by negative. So I get x is less or equal to 1 over 8. Okay, and if I were to ask you, hey, graph the solution, once we graph it, this is 1 over 8, and I want x's that are smaller than and equal to 1 over 8. And remember, numbers are smaller going this way to the left of a number. So in other words, I'll write a bracket because this symbol here means I can include the 1/8. So this would be the solutions that make this drawing represents the solutions that make this inequality statement true. And again, for interval notation, this just means negative infinity to 1/8. And if you have trouble understanding as to why I did it this, as to how to make sense of this interval notation, I will discuss it in a separate video. All right. So for those of you who would like more comments, more problems, drop a comment in the videos, and I could do more problems of solving these. And remember to like, share, and subscribe. And thank you for for watching.